All right, now we're going to look at problems where your a right here is not 1. And so the first thing we want to do when looking at problems like this, or any factoring problem for that matter, and I mention it now because I wanted you to get the basics down, the first thing we do is factor out the GCF on any factoring problem. So we check and see if there's a GCF here. So I see 3, -2, and -5. There's no common factor between those three numbers. Now I may proceed into factoring this out using another method. All right? And so the method I'm going to use to factor this out is called grouping. And I'll show you what I'm going to do. The first thing I want to do is notice that the a is not 1. So that means I'm going to have to multiply or find the product of my a and my c. My a is 3 and my c is -5. That gives me a product of a -15. I'm going to find the factors of -15 that give me a sum of -2. Well, I know 3 times 5 is the numbers or the factors I associate with 15 most commonly. And so I know this has to be a negative when I multiply them, so one of these need to be negative, and they need to be negative in such a way that when I add them, I will get a -2 back. So that means the 5 would have to be negative. So what I'm going to do is rewrite this expression out with my with my -2 written as 3p minus 5p. Let's see it. 3p squared, that's a positive 3p, minus 5p, minus 5. Now, if you look, I'm getting this 3p minus 5p from this -2p. When I add them, I'm going to get -2p. Also, 3 is here. That's where my 3 comes from. And -5 is here. That's where my -5 comes from right here. Now I can factor via grouping. Remember that all of these are being added. Even though you see these subtraction signs here, think of them as adding the opposite. And so I'm going to look at all of these as being added. So when I group them, I'm going to know that I'm not multiplying anything, I am adding. And so that's going to help me when I put my grouping symbol around this negative. Since I'm adding, then I need to put an addition sign right there to help me remember that I'm adding. Now I can factor each group. And so I see they have a 3 in common. They also have a p in common. So I'm going to take out a 3p and put what's left over. If I take out a 3p here, I'll have a p left. If I take out a 3p here, I'll have a 1 left. I can also take out what they have in common here. They have a -5 in common. And what's going to be left, if I take out -5, I'm going to have a p left. And if I take out -5 from here, I'm going to have a positive 1 left. Now what I'm going to do is create my double bubble. I'm going to notice that the common factor here is p plus 1. An expression can be a factor. And so now that I know that this expression is my factor, I'm going to put it in one of my factoring bubbles. Then I'm going to realize that this is what's left over, 3p minus 5. And so I'm going to put that into that factor. And then I'm all done. That's the first one. That's number 1. We're also going to do number 2, and then we're going to skip to number 8. In number 2, we have the same issue. Let's look for the greatest common factor. I see 2, I see 3, I see -9. They don't have a common factor between them, so I'm going to multiply the a and the c, getting a -18. I'm going to find the factors of -18 to give me a positive 3. Numbers I associate with 18 are 6 times 3. Of course, 9 times 2. 1 times 18, and so forth. The number that's going to help me the most is 6 times 3. One of them needs to be negative. If I'm going to add them together, the one that would need to be negative to give me a positive 3 when I add them is the 3. 6 minus 3 is a positive 3. So I'm going to rewrite this with these in my expression instead of 3p. So that's going to be 2p squared plus 6p minus 3p. That's where I'm going to get my 3p from, minus 9. Everything is the same except for that middle term. The middle term is being rewritten so that the factors are going to equal this product right here that you set out at first. So now I'm going to group. Remember, if I group around that negative symbol, make sure I put the plus sign there to remind myself I'm adding there. Now, I'm going to see what they have in common. They have a 2 in common. 2 is a factor of 6. And they have a p in common. So I'm going to take out 2p. And I'm going to have p left over for that first term. And I'm going to have 3 left over for the second term. Good. I'm going to look here. I have a negative 3 in common. I'm going to have p left over for the first and a positive 3 for the second. You can check that using the distributive property. Negative 3 times p is negative 3p. Negative 3 times 3 is a negative 9. Create your double bubble. The expression they have in common is p plus 3. And what's left over is 2p minus 3. And it's factored. All right. Last but not least, a problem in which we'll have to solve. Also, this is a problem which I specifically selected so that you'll have to factor out the GCF. So let's look at the numbers 9, 66, and 21. They all have factors of 3. And so I'm going to take out a 3. When I do that, I need to divide each of these by 3 so that when I use the distributive property, I'm not going to, but what you need to understand is we are undoing multiplication here. So if you were to use the distributive property, you'd get your original problem. So that'd be 3f squared plus 22f plus 7. Now I am left with 3 times this expression here. And so what I need to do is factor out this expression here. And so I'm going to remember that 3's there, but I'm really going to be working with this. All right, and so I'm going to have, I don't have any more GCF, so I need to multiply my A times my C, in which case I'll get 21. Find the factors of 21 that will get you 22. 1 times 21, we could stop there because 1 plus 21 is 22, and they're all positives here. So I'm going to say 3f squared plus 1f, which is just f, plus 21f plus 7 equals 0. Factor using grouping. I don't have to remember that there's a positive sign there this time, or that I'm using addition this time, because there's no negative sign. I could just put the grouping symbol around the 21. They both have an f in common. Take out your f. I'm going to have 3f plus 1 left over. These numbers both have a 7 in common. Plus sign, bring that down. Take your 7 out. What's left over is 3f plus 1. You can check that using the distributive property. 7 times 3 is 21f there. 7 times 1 is 7 right there. I'm going to move this up here. Create my double bubble. And don't forget, 3 was a factor originally, if we remember right there. So I'm going to put that right there as well. Then the expression they have in common is 3f plus 1. And what's left over is f plus 7. And so I have 3 things that are going to equal 0. 3 equals 0, which is extraneous. F plus 7 equals 0. And 3f plus 1 equals 0. Then I would solve for each one. In this instance, f equals a negative 7. And in this instance, f equals, subtract 1 from both sides and divide by 3, a negative 1/3. And then those are your solutions, or your roots. And so let's go through the steps. Factored it out, factored the 3 out first, and factored out the trinomial, and then solved for your variable. All right, make sure you do 1 through 10.